morning, guys. This is lesson 4 of the probability unit. This will be a 2-day lesson. We're going to be talking and reviewing Venn diagrams, actually, which is something that you did see in middle school. So in our Do Now, in a school of 90 students, 40 play lacrosse, 25 play tennis, and 5 play both lacrosse and tennis. So in a situation like this, we use what's called a Venn diagram to organize the data. So what we would want to do is make a rectangle, and then based on the number of items that you're talking about, you would make that many circles. And since we're only talking about lacrosse and tennis, I only made 2 circles. So the intersection is where both items are satisfied. So we're talking about lacrosse and tennis, so always a good idea to label with a letter that's appropriate. So there's 5 students that play both lacrosse and tennis. So the 5 would go in the center here. And typically if you're given the and statement, which again coincides with the middle value, you always want to insert that first, okay? So for the L circle, we have to understand that the 40 people that play lacrosse, 40 has to be the summation of the entire L circle. So the common mistake is that students put 40 here. But if you look at our two totals in the entire lacrosse circle, 40 plus 5 is 45 students that would play lacrosse, and we need 40 students to play lacrosse. So what we have to do is we have to take the inner value, the 5, and we have to subtract it to get 35. So that means that 35 students play lacrosse but not tennis. 5 students play lacrosse as well as tennis. So 35 and 5 gives us the total of 40 that we need. So likewise for the tennis. So there's 25 students that play tennis. So again, the common mistake is that students would put a 25 right there. But if you look at the entire tennis circle, the summation of both of those numbers is 30, and that's not what was told to us. We were told that a total of 25 students play tennis. So we have to take that inner value and subtract it over. So 20 students play tennis but not lacrosse. 5 students play tennis as well as lacrosse. So 20 plus 5 gives us the total of 25. All right. Now also you're going to be putting a number in on the outer edge of the circles inside the rectangle. And that would be this to account for the students that don't play lacrosse and also don't play tennis. So notice that there were a total of 90 students in this particular school. So right now we have 35 plus 5 plus 20, right? So 35 plus 5 plus 20. So right now we're talking about a total of 60 students, right? So 90 minus 60 would be 30. So sometimes it's also important to know this outside number. There's 30 students that don't play lacrosse and they don't play tennis either. All right, so let's get to some of the questions. How many students play lacrosse or tennis? So the and word implies that we're only talking about the middle value. The or statement tells us that we're actually talking about the summation of all numbers in the circles. So or would account for students that only play lacrosse, only play tennis, or both, right? So 35 plus 5 plus 20, we actually totaled that up over here already, that would be 60. What is the probability a randomly selected student plays lacrosse or tennis? So now we're talking about probability. There was a total of 90 students, so 60 over 90. What percent of students play lacrosse to the nearest tenth, right? So it doesn't specify that they can only play lacrosse. So we actually have to account for the entire L circle, right? So we have 35 plus the 5. That would give us 40, right? But it said what percent of students play lacrosse. So we would have to take 40, divide it by the total, and then pick up our calculators. And that would give us this decimal. We would multiply by 100. And now we would round to the nearest tenth of a percent. So about 44.4% of the students play lacrosse. Okay. So in this next exercise, okay, we're not really talking about specific values like we were in the do now. We just want to get used to what the shading of each diagram would represent in words, right? So we did go over a couple of the keywords just now, and again, correlates to the middle value. The or word correlates to the summation of all the numbers in the circles, right? So the left side, the middle, and the right side, all right? Let's take a look at some of the other ones, right? So this is sort of just a matching exercise. So I noticed that in option 2 over here, we have shading of everything in the circle. So that would represent the summation of all numbers inside the circle. So that would correlate to an or statement, right? So the students play soccer or baseball. Notice the symbol for or, right? Looks like a U. So this would correlate with 2. All right, so we took care of this one, right? We already spoke of this one. The middle value is simply shaded, so that correlates to the word and, right? So that would correlate to this right here. So that would match up with choice 1, right? Notice the word and the symbol. We saw that in yesterday's lesson when we were talking about proving if 2 events were independent. So we see that same exact symbol there. All right, so choice 1 is done. Okay, so plays soccer, right? So it doesn't say that they can only play soccer and not baseball, right? So when they say just play soccer in general, we're looking for the entire S circle. So that would correlate to option 3. Okay, so we're done with that one. They simply do not play soccer. So what this means is that they could play baseball, or they could do something else. So if you look at option 4, the shading is only in the only baseball, but also the shading is on the outer edge. See, this is not a specific statement. It doesn't say does not play soccer and does not play lacrosse, right? So we have to count for all other possibilities, right? So these would be the other possibilities. This would best match up to choice 4. So process of elimination, we have to correlate 5 with letter E, but let's just take a look at it. It says just baseball and nothing else, right? So we wouldn't want to shade on the inner portion here because that would imply that they do also play soccer. And we wouldn't want to shade on the outer edge because that could be students that play maybe lacrosse, or badminton, or basketball, or football, or something like that. So just baseball and nothing else. We would just want this B circle without the inner shaded. Okay. So this is your next model. Excuse me. Get a good view here. All right. So question number 2. Suppose 230 students play soccer, 190 students play baseball, and 60 students play both sports. There are a total of 500 students at the school. Draw a Venn diagram below that illustrates this situation. Okay. So I'll have a nice rectangle. I'm talking about soccer and baseball. So once again, I only need 2 circles that intersect. And I should label, we're talking about soccer and baseball once again. So soccer, baseball right here. Okay. So let us see. Were we given the and statement? And yes, we were. It didn't actually have the word and in it, but it implies. It says 60 students play both sports, right? So that 60 is going to go inside right here. Now 190 students play baseball, right? So once again, the common mistake is that students would put 190 over here, but that would mean that the amount of students that play baseball are 190 plus 60, which would be 250 students, which is not what this statement says, right? So we have to take the 190 and we have to subtract the inner value right here. So that's going to give us a total of 130 students that play baseball but not soccer, right? So I like to circle that value. I'll circle this one too. So likewise, it says 230 students play soccer. A common mistake is students will put 230 there and just leave it, but that would mean that there's a total of 290 students that play soccer, which is not what that statement says. So we have to take the inner value, subtract it. So that's going to give us a total of 170 students that play soccer but not baseball. Okay? We have a total of 500 students at the school. Sometimes I put the total on the outer edge of the rectangle. And I do like to find the number on the outer edges of the circles, but inside the rectangle. So that would be students that don't play soccer and they don't play baseball, right? So what we would want to do is add up all of these 3 inner numbers. I'm going to do that on the side, actually. Okay, so that's going to be 16. So we have a total of 360 students, that play soccer or baseball or both. So if we take the total, which is 500, and we subtract the 360 students that play soccer, baseball, or both, we're going to get 140 students that don't play these sports at all, right? So that's also a key number. Okay, a really good check is make sure that the number on the outer edge of the circles and the 3 numbers in the circles, make sure that they do add up to be the total. All right, it's really nice, like check and balances. So we have 140 plus 130 plus 60 plus 170, and check it out, it comes out to the 500. All right, really nice check to make sure that your numbers are accurate. Right? So letter B, how many students play soccer or baseball, right? So again, we have that word or, and or is when we add all numbers in the circles, right? So we have the 170 plus the 60 plus the 130, which actually we did over here. So we already have the answer, 360 students, right? Okay, now we're going to draw a new Venn diagram. Now this new Venn diagram is going to illustrate the probabilities of each section of the diagram, which is a very easy procedure. Okay, so when we talk about probabilities, right, we're talking about a quantity over some sort of total, right? So we have the total number of students, which is 500. So to do a probability Venn diagram, what we're going to do is we're just going to take each of these 4 numbers and simply divide it by the total. And then we're going to record those. All right? So let's see. So we have 170 divided by 500. So that's 0.34. Now you could choose to turn these to percents, or you could leave them as decimals, because there was no specific directions on how they wanted the probability represented. So now we're going to take 60 divided by 500, and that's going to give us 0.12. And 130 divided by 500, that gives us 0.26. And then we'll take 140 divided by 500, and that's going to give us 0.28, right? And again, another nice check and balances system is the highest probability that you can have of anything is 100%, which correlates to a whole number 1, right? So we want all 4 of these numbers to add to be 1. So again, always really nice to double check. Right? And it does come out to be the whole number 1, which again is the highest probability you can have of any event happening. So let's see, letter D. Suppose a student is selected at random from the school. What is the probability that they play soccer and baseball? The probability that the student selected plays both sports, right? So we want to understand that the and correlates to the middle value right here, and that's already a probability. So we just steal it from our diagram, and that's it, 0.12, or 12%. Letter E, suppose a student is selected at random from the school. What is the probability that the student plays soccer? That's our symbol for or. Or baseball, the probability that the student plays either soccer or baseball, right? So we want to understand that the word or implies add all of the numbers in the circles, right? So we would want to take 0.34, add it to 0.12, add it to 0.26, and that would give us our final probability. Right. So that would be an answer of 0.72. Right. So there are, let's see, there are 2 more model problems on the next page. So I'm going to stop the video now. You should try them on your own, and then as I've done before, I'm going to make a separate video for those models.